Hi everyone and welcome to this video about exponential functions. If you enjoy this video, please remember to like and subscribe. And if you have any questions about the content of the video, or you would like me to make a video on some other maths topic, please leave a comment down below. Exponential functions are functions of the form f of x equals a constant to the power of x. Exponential functions always exist in this form. A, remember, is a constant number, and we're raising that to a power of an unknown variable. For example, we can look at this graph, which is f of x is equal to 2 to the power of x, and we can identify some key features. The value of 2 to the power of x tends towards 0 when the value of x is less than 0. We can see that the value of 2 to the power of x also tends to infinity as the value of x increases above 0. For all exponential functions, the x-axis will form an asymptote for the graph. That means the graph of the exponential function will approach but never reach the x-axis. We can also see that the graph of 2 to the power of x crosses the y-axis at the point 0, 1. This is an important point for exponential functions, as all of them will cross the y-axis at this point 0, 1. If you can't see y, let's just replace the x with 0. Anything to the power of 0 is going to work out to be 1. So when the x-coordinate in an exponential function is 0, the corresponding y value will be 1. So the y-intercept is this point 0, 1 for all exponential functions. We can have a look at y equals 5 to the power of x, y equals 3 to the power of x, and y equals 2 to the power of x on the same set of axes. Let's just compare these graphs. We can see that the smaller the number at the base of x, the shallower the graph is. So on the left-hand side, below x equals 0, we can see that our red line is shallower and approaches the x-axis slower than the other two. We can also see to the right of the y-axis, it rises a little bit slower, and the steepest graph is y equals 5 to the power of x. So the larger that constant at the base of the unknown variable, the steeper the graph will be on both sides of the y-axis. A special value exists for which the derivative of the exponential function is in fact the exact same function as the original. Now this value lies somewhere between 3 and 2. So as an example, I'll differentiate y equals 3x and y equals 2x. So here I have the derivatives of both of those graphs. We can see that for 3x, if we find the derivative of this, the line is in fact now above the original function. And when we find the derivative of 2 to the power of x, our line is now below the original function. So this should indicate for a constant in between 2 and 3, the line of the derivative will lie exactly on our original function. This constant that allows the derivative to be the same as the original function is e. Numerically, the value of e is around 2.71828. It's just a constant, however, it is not an exact number. Just like pi, e is both an irrational number, however, it is a very important constant at the same time. So just to summarize what makes e such a special number, if we take the function f of x equals e to the power of x, the derivative is the exact same function. So I can write it like this, or if you're not familiar with this notation, we could also write it like this, where dy over dx, the gradient or the derivative, is the exact same function. We might find a case where the function isn't just e to the power of x, but e to the power of kx. This derivative is not hard to do. In fact, all that happens is we bring the constant down to the front of the exponential and retain it at the top. Applying these rules to some example questions, we can see that for I would take the 4 down to the front, retain the exponential, and retain the constant at the top. For part 2, I would bring the 2 down to the front, and of course, in this case, we would have to multiply by the 3 that is already there, and retain the constant at the top as well. So simplifying this one would be 6e to the power of 2x. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comments section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.